For number 18, we want to find all the rational zeros and factor f of x. There are a few approaches to doing this, and one is using synthetic division, like we did in the previous example. Another way would be to factor by grouping, if possible. When you consider all the possible rational zeros, those possible zeros are factors of 3 that are divided by factors of 4, so we have these as our possibilities. But I noticed something when looking at this problem, that it appears that it can be factored by grouping. So I'm going to rewrite the polynomial and look at the first two terms and look at the last two terms and see if I have a common factor. And what you can factor out of the first two terms is 4x squared. And when you factor out a 4x squared from the first two terms, you'll be left with an x minus 3. For the last two terms, since we have a minus x and a plus 3, I can actually factor out a minus 1, and the result is x minus 3. Now I'm looking at factoring, and by grouping, notice that I have those two common factors of x minus 3. So x minus 3 is a factor, and what's left when you take out those two common factors of x minus 3 is 4x squared minus 1. So our polynomial function can be written in this way, but we can factor even further, since 4x squared minus 1 can be factored because it fits that model of a difference of two squares, where the factors are 2x plus 1 and 2x minus 1. Since it follows that model a squared minus b squared, where the factors are a plus b and a minus b. So continuing on, we factor this into 2x plus 1 and 2x minus 1. So this again is a third degree polynomial. So we can have 3 possible factors, and we can find those 3 zeros by setting each of those factors equal to 0. So you set x minus 3 equal to 0, x equals 3 is a 0 of that polynomial function. Set 2x plus 1 equal to 0 and solve for x to get x equals negative 1/2. And set 2x minus 1 equal to 0 to get x equals positive 1/2. So those are 3 zeros of this polynomial function. If you were to graph this and adjust the scale, you would note that the graph is a third degree polynomial, so it could go in 3 directions. And the intercepts, the x-intercepts, occur at x equals 3, at positive 1/2, and at negative 1/2. So our graph could go in 1, 2, 3 directions. And of course, you can adjust the scale on your graphing calculator to see more detail in the graph. So our answer here is B. Let's look at number 19. For number 19, the graph of that polynomial function is shown, and we can use the graph to factor f of x. So what's nice about this is that when we have the graph, we can see where the function crosses through the x-axis, and those correspond to our factors. So I noticed that right here at x equals 2, the graph goes right through the x-intercept, through the x-axis. So we can use synthetic division with a 2 in the box, and we use the coefficients for x to the 4th, 1x to the 4th, plus 1x to the 3rd, minus 7x to the 2nd, minus 1x plus 6, using this setup for synthetic division, bringing down the first term and multiplying and adding. We see that we have a remainder of 0. Since x equals 2 is a 0 of the polynomial function, that means x minus 2 is a factor. So x minus 2 is a factor. And the remaining part, what's left underneath this part of synthetic division, is 1x to the third plus 3x minus 1 minus, 3x squared minus 1x minus 3. But this can be factored even further. So this is a really neat shortcut for continuing to factor if you know what those zeros are. The next zero is x equals 1. So I'm going to put a 1 in the box here for synthetic division and bring down the first term, multiplying, add with what's left over without the remainder. 1, 1, 4, 4 times 1 is 4, 3, 3, and 0. Okay, so that means we have a remainder of 0. X equals 1 is a 0 of the polynomial function, and that also means that we can factor even further. So one factor is x minus 2, one factor is x minus 1, and what's left under here is 1x squared plus 4x plus 3. Now we can factor even further, either factor the trinomial here or continue using the x-intercepts to factor. Here we have x equals -1. So I'm going to set up the synthetic division with -1, bring down the first term, multiply and add, and multiply and add. So we can continue factoring out this polynomial with factors x minus 2, x minus 1, and the last trinomial can be factored with an x plus 1, and what's left here is x plus 3. So this is our polynomial function in factored form using the graph. Notice x equals -3 is a 0 of the polynomial, so that corresponds to the x plus 3 factor. So our correct answer here is D.